Let's move to practice exercise 1. In 80 liters mixture of milk and water in the ratio of 5:3. Okay. So you have 80 liters mixture of milk and water in the ratio of 5:3. 16 liters of this mixture is replaced by 16 liters of milk. Then the ratio of milk and water in the resulting mixture becomes, okay. In this question we are adding milk. If we are adding milk, that means the quantity of milk will change, but the quantity of water will remain constant. So in such question, as is the case in this question or the previous question, you work on the basis of the item whose quantity does not change. So quantity of water in this question is constant. Why is it constant? Because it is milk which is being added. So we'll work on the basis of quantity of water. Now what are you doing in this question is, you have 80 liters of milk is to water. What is the original mixture? Mixture of milk and water in the ratio of 5:3. 80 liters of 5:3 milk is to water. Then you are removing 16 liters of this mixture, which again is a 5:3 mixture, and hence you are left with 64 liters of 5:3 milk to water mixture. To this 64 liters of 5:3 milk and water mixture, you are adding 16 liters of, as per the question, milk. So 0:1. So 16 liters, this is pure milk. Okay. So effectively, one of the things which you need to remember in this question is, you are not mixing 80 liters of mixture with 16 liters of milk. You are mixing 64 liters of mixture with 16 liters of milk. Okay. Or in other words, you are adding 1/4 or the volume of mixture from 64 liters is becoming 80 liters, or the volume of the mixture is becoming 5/4 times. If the volume of mixture is becoming 5/4 times, what will happen to fraction of water? Why water? Because we are not changing the quantity of water. Fraction of water originally was 3/8. If the volume has become 5/4 times, the fraction of milk becomes fraction of water becomes 4/5 times. So this becomes 3/10. So since the new fraction of water in the mixture is 3/10, I can say milk to water should be, water is 3/10, so milk should be 7/10. Or this implies milk to water is 7:3. Okay. Again, I have used that simple concept. If the volume has become 5/4 times, the fraction of the item which is not changing, in this particular case is water. Why is milk changing? Because you are adding a quantity of milk into the mixture. If the volume of mixture becomes 5/4 times, the fraction of water in this case will become 4/5 times of the original. Originally water was 3/8 of the mixture. Since the volume became 5/4 times, the fraction of water has to become 3/8 into 4/5, which is 3/10 times. This is a simple way of doing this question. You could have actually applied alligation also to this question. Let me just clean up the slide, and then let's see how to apply alligation. Now let's see how we could have applied alligation or weighted average as a concept for this question. You are mixing 64 liters of milk is to water mixture, which has got milk and water in the ratio of 5:3. Or I can say 5/8 is milk and 3/8 is water originally in the mixture. You are mixing this with 16 liters of pure milk, which means 1:0 or 100% milk. Okay. So let's try to apply alligation. In alligation, what you will say, if you are alligating with respect to, let's say, milk, you are mixing 5/8, a mixture which has 5/8 milk with another mixture which has got 100% of one milk, such that the average is equal to x. And this is 1 minus x, and this will be x minus 5/8, because x is the average, so it should be more than 5/8 and less than 1. Okay. And then what are these 1 minus x and x minus 5/8? These are nothing but ratio of quantities. What are the ratio of quantities? 64 as well as this one is 16 liters. So this will imply 1 minus x upon x minus 5 by 8 is equal to 64 by 16. Okay. This would mean solving this equation. Now, which means you need to remember that if you have to find one of these three things, you should not use alligation. No alligation should be applied if one of these has to be determined. But you should be applying weighted average. Weighted average is the right approach if one of these has to be found. Use alligation only if the ratio of quantities has to be determined. In this question, the ratio of quantity is given. So alligation was a wrong approach. While this will give you the answer, this will make your question lengthier. So just to repeat, you have P1, you have P2, you have an average, and this gives you ratio of quantities. To determine ratio of quantities, apply alligation. To determine one of these three variables, you should apply weighted average. Please remember this part. Let's come back and let's solve this question using weighted average. In terms of weighted average, what would you do? Let's look at fraction of milk. The fraction of milk in the 64 liter mixture is 64 liters into 5 by 8 plus 16 liters into 1, which is because it's 100% milk. This will mean the quantity of milk will become so we'll have 56 liters of milk. What was the total quantity? The total quantity is 64 plus 16, which is 80. So milk is 56 liters. Water has to be 24 liters. So what will be the ratio of milk and water? Ratio of milk and water will be equal to 56 is to 24, which is 7 is to 3. Okay. As you would notice, probably the fastest method is actually taking the ratio which we started with originally, that the volume of the mixture has become 5 by 4 times. So fraction of milk in the fraction of water in the mixture should become 4 by 5 times. With this, I have completed what I think are the important questions of exercise 1. I have tried to, as I said earlier, use the choices. I have tried to give you simple concepts with the help of which you can solve the question. My approach always is, if there is a question with choices, you have to use choices because that will help you work faster. And those 30 seconds, 1 minute or couple of minutes that you save on every question will help you do a couple of extra questions in the paper, which will get you closer to an interview call. With this, let me close the session for practice exercise 1. We will now move to practice exercise 2.